everyone. So today we will solve Leetcode problem 33, search in rotated sorted array. So it states that we are given an array which is sorted, which was initially sorted, but then it was rotated by some pivot index. So we can see that here it was rotated along 0. So initially the array was sorted in ascending order, but then it was rotated by this index. So now all the elements greater than this value lies behind it. So now since it's a rotated sorted array, we need to find the element whose value is equal to target and then return the index of that element. So we can see that here index 4's value is 0, so we return 4. Here none of the value matches target, so we return -1. Similarly here also we return -1. So now first thing is, if it was just sorted array and it was not rotated, then it would be pretty easy to find the target elements index just by doing a simple binary search. But now since it's rotated, we need to find an element by which it was rotated. For example, here 0. After finding the element by which it was rotated, we can divide the array into two parts. One is this part and the other is this part. So we will divide the array into two parts. Now we can individually apply binary search on this part or on this part, depending on where our target element will lie. So we can easily figure out where we will apply binary search on which subarray, either on this one or on this one. So here we can see that our target element value is 0, which lies between the pivot point and the end of the array. That means we have to apply binary search here. If our target element value was suppose 5, then we can see that 5 value was greater than this but also greater than this, right? So that means we needed to apply our binary search on this part then. So let's code this up. First we'll find out the pivot point and then we'll apply binary search on the subarrays. So we'll declare values big is equal to 0 and equal to length of nums minus 1. Then we will do for big is less than end. We will initialize mid. Mid is equal to big plus end minus big by 2. Now we will check if by any chance our nums mid is equal to target, then we'll just straight away return mid, because then we don't have to apply binary search on our subarrays. But if our nums mid is greater than target or nums end, we will do so here in this case we can see that our nums mid is greater than nums end. So what does this imply? This implies that our mid value is greater than our end value. That means we are at here, like suppose this array length is 7, right? So so 7 by 2, this array mid will be equal to 3, 0 1 2 3 here. So here we can see that a 7 is greater than 2. That means our pivot point lies ahead of this. Our pivot point lies ahead. So what we will do, we will just do big equal to mid, else we will do end equal to mid minus 1, right? So at this point we have found our pivot point. And our pivot point is equal to big. So we'll first initialize start equal to beginning, so as to store this value somewhere, so as to store the pivot value somewhere. Then we'll reinitialize big and end. Now we will check in which subarray we need to apply our binary search. So we will check if our nums start or target. If our target is greater than equal to nums start and target less than equal to nums end. So that means this is the case. So we'll apply binary search here. So we'll update our back is equal to start. Else we will update end equal to start. And now to apply the final binary search for big less than end. I'll just do less than equal to here. We will reinitialize mid is equal to big plus end minus big by 2, and then we'll check again if our nums mid is equal to target, then we'll return mid, else if nums mid. This is our typical binary search algorithm. Now if our nums mid is greater than target, so we'll have to initialize end equal to mid, else we will initialize big equal to mid. And even after this step we haven't found a target element, that means our target element does not exist, so return -1. Now let's run this up and see if it works. Also I'll have to do end mid -1 plus 1. I'll run this again. So we see that our one test case fails. It says -1 and answer is 1. Let me do it here +1 and remove -1 here. So it says time limit exceeded. Let's see. Let me just remove this again, add +1 here, remove the equal to sign from here and add it here, and let me run this now. And yes, it does work. I guess we needed the equal to sign here because in case our target is equal to num start, then also we want this to run. I'll submit it now, and it does work, and we can see it's pretty efficient. That was all for today, and I'll see you in next one. Thank you.